Before we start this video, a large thank you to Xander, Robert, Sam, Quentin, Jonathan, Yang, Emile, and Salo for their support on Patreon. I hope you guys enjoy the video. And an absolutely immense thank you to Halo Burner and Sora Stratos for their support to the channel this month on Patreon. I greatly appreciate it, guys, and I sincerely hope you enjoy the video. Hello everybody, and today we're going to make the combat stance state, and we're going to make some AI character attacks. So before we get into what the state's going to do, let's right click in here in the AI character folder. Let's create a new C# script. I'm going to call this combat stance state. Call it whatever you want as long as you know what the state is for. I'm going to explain that in just a moment. So next I'm going to right click, create another script, and I'm going to call this AI character attack action. So this is just going to be basically a scriptable object that's going to store an attack for us. It's going to give us some information like the angle and the distance needed to perform this attack, etc., etc. But yeah, we'll get to that in a sec. Okay, I'm just going to right click also. I'm going to create two new folders just to keep this a bit organized because we are getting quite a few scripts here. I'm going to create a new one for states, and this is just going to store all of the AI character states. And then I'm going to create another one for actions, and I'm going to put my AI character attack action in there. And in the future, if you want to make any actions, they can go into this folder. Okay, cool. So now I'm going to explain what the combat stance state is going to do. Alright, so what is the combat stance state? The combat stance state is the state we switch to when we're within combat distance of our current target, and here it's where the AI decides what action it's going to take. So, we want to sort through all possible attacks and select an attack based on distance, angle, and weight. What does this mean? Well, we have a bunch of attacks we can perform, but there's only a certain set of those attacks we can do in each specific instance. So for example, if one attack requires you to be quite far away from your target and you're very close, that attack is not possible to perform here, so we're going to just take that attack out of the list for now. So the same is true with angle. If some attacks require your target to be behind you, some require your target to be to the left or to the right of you, but they're not, you remove those as well. And lastly, weight is how likely the attack is going to occur over, say, another attack. So some attacks will be far more likely than others. Next, we're going to check if we are too far from the target, then we're going to return to our pursue target state to again try to close that distance. And then lastly, if the target is no longer present, we're going to return to the idle state. If we have an attack, we're going to switch the attack state. In future videos, we're going to cover basically doing blocking and dodging. So this is while you're waiting to attack the target, you're in the combat stance state. And if the target tries to attack you, you can block and dodge, etc. And then lastly, we're going to handle strafing and circling patterns. So basically, while you're waiting for your cooldown or to get another attack too, the AI can try to circle around the player, strafe around them, or maybe even try to flank them. In a lot of circumstances, though, too, the AI will just simply walk at them. It kind of depends on the intelligence of the AI or what you're going for. All right, so let's jump back to the video. Okay, let's go to the combat stance scripts, and let's delete the start and update method and add in our namespace as is per tradition. And I'm just going to make this derive from AI state so we can incorporate the override of the tick. And I'm going to start by writing some comments about what we're going to do here because I think that's a great way to start any kind of functionality. So one, we want to select an attack for the attack state that we're going to pass. And again, we're going to do this based on the distance and angle of the target in relation to this character and the weight of the attack. So we're basically going to go through every possible attack this character has and pick the ones that are possible. And then from that list, we're going to pick one at random depending on the weight, and we're going to pass that attack to the attack state. Also, we're going to process any combat logic here whilst waiting to attack in the future. So this is like blocking and strafing and dodging. That's going to be in a future video. For now, we're just going to get the basics down. So this AI will try to pursue you and attack you. Next, we're going to say if the target moves out of combat range, then we're going to return or switch to the pursue target state. So that will keep our states kind of like in a loop or a circle. Likewise, if the target is no longer present for some reason, then we're going to switch back to the idle state, and that will just kind of, again, reset the AI character. All right, cool. So that's a great few things to start off with. Let's start off with number one here. Select an attack for the attack state. So I'm going to make a header, call it attacks, and I'm going to make a list, and this is going to be for all the possible attacks this character has in their arsenal. So a public list, AI character attack action, we'll call this AI character attacks. And again, this is every single attack this character possesses that it may do. This is not the current attacks that it's going to select from right now. The next list, though, is just that. So private list, AI character attack action, and we'll call this potential attacks. And this list is basically every version of the whole list that is possible in this moment. So if there is, say, 6 attacks in your total attack list and 4 of them are possible in this moment based on distance and angle, then it will have 4 of those attacks out of 6 in this private list. And then from there, we're going to pick one at random to do during the attack state. All right, so I'm just going to add a comment, a list of all possible attacks this character can do. And the second one is a list that is created during the state, all attacks possible in this situation. And honestly, we can just say all attacks possible in this situation based on angle distance. We don't need to make the comment that long. I think that's enough. So right below here now, I'm going to make a header for combo. And we're not going to incorporate this in this video. It will be the next one when we get around to actually doing the attack state. But we're going to make the logic for it here because it is a part of the combat stance state. And I'm going to change private to protected in case we want to make different combat stance states for different characters in the future. And I'm going to likewise put a protected bool here for can perform combo. Can initialize to false. So what is this? This is basically a setting that allows you to make it if your AI can or cannot attempt to perform a combo. And we're going to do it based on a chance system. So we're going to make a protected int. This is going to be a chance to perform combo. This is in a percentage, so I'm going to say default 25. You should make this between 0 and 100. And then we're going to make a bool for has rolled for this chance. Now you could make it so the character combos every time if they connect a hit. I can show you how to do that too if you guys want, or you can make it so it's entirely random like this. I kind of prefer this system because it's a bit more chaotic and harder to read. Next we're going to make a header for the engagement distance, and this is the distance at which the character will be okay with maintaining this state. And if you go outside of this distance, like past it, we're going to switch back to the pursue target state. So make that a protected float maximum engagement distance. I'm going to initialize mine and say 5. And I'm just going to make a comment here. The distance, we have to be away from the target before we switch back to the pursue target state. So this distance will definitely differ heavily depending on what kind of enemy you're making. Some enemies, for example, might have ranged attacks, so you can have the distance be a lot larger. Others might be very close up to you, so you can have the distance be a lot smaller, entirely up to you. So again, I'm going to add some comments to keep this very clear. If the character can perform a combo attack after the initial attack, that's what this bool is for. This is the chance in percent of the character performing a combo attack during the next attack. And this bool down here just shows if we've already rolled for that chance. We're going to roll every time we enter the state. And when we leave the state, we're going to reset all this stuff so we haven't rolled. So if you want to, you can actually remove the serializable field from that too. I just have it there so I can see it in the inspector. But if you don't want that to appear there, because you don't actually need to mess with that setting at all, you can just erase the serializable field. I'm going to call in now the override and tick. Not going to do anything with it yet, just put it up there. And I'm going to make a new function, a protected virtual void get new attack. I'm going to make it require an AI character manager variable. I'm going to call that AI character. Okay, so we're going to make another function right below that. Going to make it again a protected virtual bool this time. And we're going to call this roll for outcome chance. And I'm keeping it general because we're going to use this for multiple outcome chances. Going to make it require an int. Going to call it outcome chance. So for example, you can roll to see if your character is going to block this time or dodge the next attack, etc., etc. Next, we're going to override the reset state flags and call that. And we're going to place in here has rolled for combo chance, because we don't want to keep the outcome of that every time we come back. We want to get a new outcome every single time. So that way you're rolling every single time you enter the state to see if you will perform a combo when you leave and go to the attack state. I'm going to switch this to a protected instead of private. I'm going to erase the serializable field because I don't need to see that in the inspector. And let's start off by filling in the logic here under roll for outcome chance. So let's make a bool called outcome will be performed and initialize it at false. And this is very simple. We're just going to use a int here called random percentage. Going to initialize it at random dot range between the values of 0 and 100. If you want to do 101, you can, because I believe it excludes the number there on the end because it's an int. And we're going to say if random percentage is greater than outcome, then what we're going to do, if random percentage is less than outcome, then what we're going to do is say outcome will be performed is equal to true. Otherwise, it's still false, and we're just going to simply return outcome will be performed. So basically, this is going to work on a percentage between 0 and 100, and right now you see we have a 25% chance to perform the combo. So 1 in 4 times you're going to perform a combo. So let's go to get new attack now, and let's make some comments what we're going to do here. 1, we're going to sort through all possible attacks. 2, we're going to remove attacks that can't be used in this situation. So for example, if we're too far away for an attack to be performed, or if we're too close, or if we're out of the field of view of that attack, etc. 3, we're going to place the remaining attacks into a list. 4, we're going to say here we're going to pick an attack from that list. And this is based on like weight. So the higher the weight, the more chance we're going to get that attack. So we'll say randomly based on weight. And then lastly, 5, we're basically going to take that attack here now and we're going to pass it to the attack state. And that will be the attack the AI will perform when the state switches. All right, cool. So let's save that. And let's just start by hammering out some logic. So let's go back now into the project. I'm going to go into the actions folder and open up our AI character attack action. And let's erase the start and update functionality, drop in our namespace as is per tradition. This is going to be a scriptable object, by the way. And let's start writing some logic here for our AI character attack action script. So what do we need here? Well, we're going to need a public void attempt to perform action. This is where we're actually going to play the action animation and do anything else there that requires any form of setup. So we'll make this require an AI character variable, call that AI character. And now we can actually start writing in some of the variables again. I'm going to make this derived from scriptable object. All right, so let's start by making a header, and I'm just going to call the header combo action. And basically, every action is likely going to have a specific combo action. If you want, you can make a list or a random array of them. If you want different random combo actions, you can select one randomly. But I'm going to make a singular variable here for now. So I'm going to make a public AI character attack action variable, and I'm going to call this combo action. And basically, if we roll for a combo chance, and we can combo, then after we perform the initial attack, when a bool switches on the AI character that says they can now combo, then we're going to play this combo action. You can have a bool here for action has combo if you want, and then if the action doesn't have a combo, but the AI character can combo, then nothing will happen. Or, alternatively, you can just check for null. So if the AI character can combo and this action does not have a combo action present, then nothing will happen again. Both are valid, totally up to you. Whatever you prefer, what looks needed to you. I'm just going to check for null, so I'm going to delete this. Okay, so I'm going to make a header now for action values. And this is a very general header, but the logic here is going to be pretty broad. So for example, we're going to have a public int for the attack weight. And again, this is going to be somewhere between 0 and 100. That's one we keep mine as. And then I'm going to have an attack type comment here if you want to include that, and I'll show you what I mean in a moment. Then in the future, we're going to do, can this attack be repeated? So if we look through our list of attacks and you've already done this attack last and the attack can't be repeated, then we'll skip this attack. We're going to have a public float for action recovery time. I'm going to initialize it to say 1.5. And this is the time after attacks it takes before the AI character can again perform another attack action. Keep in mind that while you're comboing, it's going to take the recovery time of the second action, and it's still going to perform the combo action if it already performed the first action. So this won't affect combos. This will only affect when the complete action is done. Next, we're going to have a public float minimum attack angle. Going to initialize that to say minus 35, and a maximum attack angle of say 35. This is pretty general stuff. That means like right in front of you in your immediate field of view, typically. Then we're going to have minimum attack distance. I'm going to say 0 and maximum attack distance. Since I'm making an undead zombie here, I feel like maybe 2 or even 1 is probably fine for most of these attacks. So I'll say 2. Now under attempt to perform action, pretty straightforward. All we do is say AI character dot character animator manager dot play target action animation. And now we need to pass a string. And I realize now I forgot to put a variable for the actual attack string. So let's do that, the attack itself. Let's make a header up here. You can call it attack or attack animation or whatever's more clear to you. I'm just going to call it attack. And I'm going to make a serializable field for a string here. And this is just going to be the attack name or the action name. Again, whatever you prefer. You can make it private or protected. I'm going to make it private for now because if we want to make different kinds of actions, they're probably going to have their own scripts. So I'm going to pass the attack animation. And then I'm going to say true, we are performing an action, and defaultly we are applying room motion, we cannot rotate, and we cannot move. Cool. Now, what if you want to use the play target attack action animation? That's valid too. So if you want to do that, what we want to do now is right here where I got attack type, we can just basically store an attack type on this script logic. Now, why would you want to do this? Well, maybe you want some special logic to occur if your AI makes a certain kind of attack. Like say, maybe all of your AI's light attacks are parryable, and you would change parryable to true based on that. Or maybe all of your AI's heavy attacks have a special effect. Who knows? But you can have that there. So I'm going to keep it here for now because we are going to use it in the future. It is not completely necessary though, but it is there, and we should capitalize on that. So I'm going to save that. Let's go back now to get new attack. Let's say potential attacks, as in the list we already created up here, is equal to a new list of AI character attack actions. So every time we run this function, it's going to create a new list and clear out everything that was in it previously. So for each attack inside AI character attacks, we want to check for some stuff. So we're going to use a for each loop here now to iterate through each and every one of them. And we're going to check some parameters and see if they can be added to our potential attack list. So we're going to start by saying if potential attack dot minimum attack distance is greater than the AI character. And I realize now we don't have a way to measure for our distance from our target. So let's go do that. So let's jump over to the AI character combat manager. Let's make a public float and call that distance from target. I'm going to put it under the header target information. And we're going to set this distance on the AI character manager. So let's jump over to that now. And we're going to set it in the same place we set the angle. So down here, if the target is not null, otherwise you will get an error if you try to set distance on this now, we're going to say AI character combat manager dot distance from target is equal to, very simple, we're just going to use a vector3 dot distance between the transform dot position, as in the transform dot position of the AI character manager script, which is your AI character. And then we're going to compare that to the position of the AI character combat manager dot current target dot transform dot position. So that's just going to measure the distance between both those points and give us back that number. Pretty straightforward. Now let's go back to the combat stance state, and we're going to say if the minimum attack distance is greater than the distance from the target, then we got to return. Or sorry, we got to continue and skip this attack. We continue because we are in fact way too close. Likewise, if the maximum distance is less than the distance from the current target, then basically the target is too far away and we should continue because we are too far away. So check the next attack. And I'll make some comments here so this is very clear before we move on actually, just so we come back and see at first glance. If we are too close, then basically continue and move on to the next attack and check the next one. Likewise, if we're too far, then check the next attack, continue, go on to the next one in this loop. So let's do the same now for the angle. And let's check the minimum and maximum angle. Basically, if we're outside of the field of view, we want to do the same thing. So we're going to say if the potential attack dot minimum attack angle, we're going to compare that to the viewable angle here. So we're going to say if the minimum attack angle is greater than the viewable angle, continue. And then likewise, we're going to say if the maximum attack angle is less than the viewable angle, we're going to continue. All right, so I'm going to make a comment here, just again, doing more or less the same. I'm just going to kind of reference here what we've wrote out just in a simple statement. So at a quick glance, we can catch that and see exactly what this is doing. If the target is outside the minimum field of view for this attack, check the next attack. Likewise, we're going to make another comment. If they're outside the maximum field of view for this attack, check the next attack. Okay, so what happens if they pass all of these checks? Well, we've got 1 and 2 done here. Now we sort through the attacks. We're removing the attacks based on distance and field of view. So number 3 says place remaining attacks into a list. All right, cool. Let's add potential attacks dot add this potential attack. So if it makes it through all these checks, it makes the list. Now 4 and 5, we got to pick one of the remaining attacks based on weight, and then we select this attack and pass it to the attack state, which doesn't exist yet. So we're going to say if potential attacks dot count is less than or equal to 0, return. That's a problem. You can put a debug message here if you want to, because maybe you forgot to put in your attacks as scriptable objects. You should throw a message if you want. That way you'll know what's up, because otherwise nothing will happen here, and you'll probably be stuck on the combat stance state forever. Next, we're going to say, we're going to make a variable here for total weight. We're going to initialize that at 0. And we're going to say for each potential attack in potential attacks again. So I'm just going to say for each attack in potential attacks, we just want to simply say total weight plus equals attack dot attack weight. And right below that, we're going to say another variable here for random weight. I'm going to call it random weight value equals random dot range 1 and total weight plus 1. Then we're going to say var processed weight is equal to 0. And then we're going to do another for each loop. And we're again going to reference each attack inside potential attacks. And inside this for each loop here, for each attack and potential attacks, we're going to say processed weight plus equals attack dot attack weight. All right, so here's where we're actually going to get the attack now. We're going to say if random weight value is less than or equal to processed weight, then we're going to say this is the attack. So we would pass this on to our attack state. We also might want to keep track of our current and previous attack. The previous attack for if you have already used this attack in the past and you don't want it to repeat. So I'm going to make a private AI character attack action, chosen attack. That's the one we just chose. And let's make one for the previous attack, which is the one, again, we just chose. But when we come back into the state again, this variable will still be the same as the last time we exited. So previous attack. Okay, now we come down here and we're going to simply say the chosen attack and the previous attack is equal to this specific attack. And this is not supposed to be random.rotation. It's supposed to be random.range. So we're going to say chosen attack equals attack. And then we can say previous attack equals chosen attack. All right, cool. So that should be working as intended. We won't know until we test it though. And I'm sure we'll know if something's gone wrong. So I'm going to save this now. Let's scroll back down here now. And actually right below this, I'm going to say has attack is equal to true. We don't have that bool yet, but we're going to make that. We need to know if we have an attack. Otherwise, if we don't, we got to keep searching. And if we do, we got to change the state. So let's make a protected bool has attack is equal to false. When we get one, that's when we leave and go to the attack state. Let's also reset this flag here for has attack under the reset state flags. Otherwise, you'll always have one. And you don't want that because you'll be repeating the same attack over and over again when you come back into the state. Okay, cool. So that's good. I'm going to go over to the tick portion now. And let's actually place in some functionality of what we're going to do in the state. So first, let's check if we are performing an action. And if we are, we're going to simply return this and do nothing. Next, we're going to say if the AI character does not have the nav mesh agent enabled, we want to enable that. So we're going to say AI character dot nav mesh agent dot enabled equals true, because again, we're going to be moving around during the state, especially in the future when we're strafing around our target. We're going to make a comment here. If you want the AI character to face and turn towards its target, if they go outside of the field of view, then I want you to run this logic. So you guys don't have to include this, but again, I like it. So basically, if you're strafing around the character and you go way outside of its field of view, instead of like walking in a circle around you, it will stop and just pivot towards you. So I'm going to say if the AI character network manager is not moving, we don't want to do this if we are moving. I mean, you can if you want, actually. We're going to say if AI character combat manager viewable angle is less than minus 30, or I'm going to copy this, and we can say greater than 30. That's the general field of view, or if you want to use 35, that's cool too. Then we can call our function that we created in the last video, AI character combat manager pivot towards target. And this is especially cool because if you go somewhere where your AI can't get to, they will no longer be moving, but they'll stop and stare at you. But if you move around in this place, like say you're above them on a platform, they'll actually just pivot towards you to watch your movement. I don't know if you guys watched any of my devlogs, but that's some functionality I've had with my undead. So next, let's make a comment and let's say rotate to face our target. We're going to make that function later. It's just going to constantly rotate to face you while you're walking around. If AI character combat manager current target is null, we're going to return switch state and we're going to switch back to our idle state. So we pass the AI character and then the AI character idle as an idle state. So again, I'll make a comment. If our target happens to no longer be there, we're going to return the AI to the idle state, and that will reset everything. And because we reset our state flags on switch state, all that stuff is handled as well. All right, so what's next? Well, we're going to say if we do not have an attack, we need to, of course, get an attack. So this is going to continually run until an attack is found. And you might not be able to get an attack in some circumstances because maybe none of your attacks meet the requirements. If that's the case, then we're just going to sit in this state and keep trying. So if we do not have an attack, get one. Else, what do we do if we have an attack? Well, let's open up some curly braces here and make an else statement. If we do have an attack, this is where we would do some logic and then switch to the attack state. So what would we do? We'll make some comments here. We're going to add this stuff in future videos. The next one for most of this stuff, check recovery timer and pass the chosen attack to the attack state. We're going to roll for a combo chance or roll for any combat outcome really. So if you're going to do anything else here that requires you to roll for a chance before we switch states, here's where you do it. And then we switch states. Okay, cool. So what if we're still waiting around and we don't have an attack, or we do have an attack, but our recovery timer isn't there yet? Well, we're going to compare the distance from the maximum engagement distance, and if we're beyond the maximum engagement distance, we're going to switch back to the pursue target state. So we can say here, if we are outside of the combat engagement distance, and if you want to, you can put this before getting a new attack. This one doesn't matter too much as to where it is in the order of operations. But make sure it's after where you have your nav mesh agent enabled if you're not enabling it when you enter the pursue target state. All right, let's save that now. Let's go into the pursue target state and copy these last few lines of code because we can reuse these now. This is basically just going to get a path to the current target, and we're going to walk towards them. Now we're going to say using Unity engine.ai. That will allow us to use the nav mesh agent stuff, and then that will get rid of that error if we have it, and yes, we're good to go. Okay, cool. I'm going to copy the create asset menu name again from the pursue target state, and I'm going to paste it up here, and I'm going to simply say AI/states/combat stand state. And lastly, I'm going to copy that again, and I'm going to go over to the AI character attack action, and I'm going to switch this to AI actions/attack action. All right, guys, so basically in the next video, we're going to make it so we will actually create some attacks, we'll cycle through all these attacks, and then we'll get the AI character to actually hit us and do some damage, and we'll test all that stuff in multiplayer to make sure it's all working. And from then on, we can expand on this logic and add stuff like strafing and combos, and we're going to do a nice little boss event so we can get a game loop going. So thank you very much again for joining me this weekend. I hope you all have a lovely weekend. A large thank you to my patrons. It's because of each and every one of you I get to keep doing this, and I love doing this. So thank you from the bottom of my heart. All right, guys, that's all from me today. I will see you all next week.